All right, so we're going to talk about how to simplify a complex rational expression, which that basically means that we have a fraction inside of a fraction. The easiest way that you can do this is to find the LCD of all your quote unquote little fractions. So basically here I want the least common denominator of 10, 5, and 3. Well, however you figure out least common denominators, go ahead and figure that one out. But basically, I'm looking for a number that's big enough for 10, 5, and 3 to go in there. So that would be 30. So what I do then is I'm going to take that 30. And the reason I am allowed to do this is because it's a fraction. This whole big piece is a fraction. It's just got a bunch of little fractions inside, which makes it look more difficult than what it is. So what I'm going to do is take that LCD and multiply by it on the top of the fraction and on the bottom of the fraction. That's just multiplying by 1. So I'm going to multiply 30 times 1/10 and 30 times 1/5. Well, 30 times 1/10 is going to be 30 over 10, which is 3. 30 times 1/5 is going to be 30 over 5, which is 6. On bottom, it's going to be 30 over 10 again, which is 3. And then 30 over 3, which is 10. Now, some of you might be thinking, don't I need to put that 30 on the bottom also? And the answer is no. It's just going to the top. Okay, this is technically 30 over 1 times 1 over 10. So it's 30 over 10. All right, 3 plus 6 is 9. 3 plus 10 is 13. And 9/13 can't be reduced. That is my answer. All right, on this one, real simple. I only have one denominator, so the LCD is 4. Well, the LCD of 4 would just be 4. So I'm going to take the big fraction and the big fraction I'm going to multiply by 4. The LCD on top and on bottom. So this 4 is going here and here. Well, hopefully it makes sense that the 4 times the 3/4, the 4 on top and the 4 on bottom is going to cancel and just make 3. And then 4 times x is just 4x. On bottom here, same thing. It's going to be 3 plus 4x. And we have to fight the urge to cancel here. 3 minus 4x and 3 plus 4x are not the same. They do not cancel. I am done. All right, on this particular one, I want the LCD of y, 4, and 8. Because these are monomials, I can treat them all separately. So y, 4, and 8. Well, let's look at the numbers. 4 and 8, the LCD would be 8, and then the y's got to come along. So I'm taking the whole big fraction, and I am multiplying by 8y on top and on bottom. So whenever I distribute this in, I end up with 8y over y. That is just 8. When I multiply it by the minus 3/4, the 8 and the 4 are going to cancel to 2y. So I'm going to end up with 3 times 2y, or 6y. On bottom, again, it's going to cancel. And then 8 times 3/8, the 8's going to cancel and leave me with 3y. Now, neither one of those, well, the top has something factorable, but it's not going to end up with 8 plus 3y on bottom. So my answer is just going to be 8 minus 6y over 8 plus 3y. And I'm done. If I factor the 2 out of the top, it'd be 4 minus 3y. All right, we got to go back to our remember in here. The LCD of x to the 5th and x to the 10th is going to be x to the 10th. Basically, it's the bigger exponent. So I'm going to take the big fraction, and multiply by x to the 10th on top and on bottom. Whoop. So on top, that is x to the 10th. X to the 10th over x to the 5th is going to be x to the 5th. On bottom, it's going to be x to the 10th. And x to the 10th times 1 over x to the 10th is just 1. Now, this one is a little bit different. And the reason why this one's a little bit different is we've got to look and realize that from here, and I'm going to have to go over here, we can factor. On top, that's a GCF. X to the 5th can come out. On bottom, that is a difference of squares. All right, x to the 10th would be x to the 5th squared, and 1 would be 1 squared. So I would end up with x to the 5th minus 1, x to the 5th plus 1. Those minus x to the 5th minus 1s can now cancel, and I'm left with x to the 5th over x to the 5th plus 1. You're going to want to, but you have to fight the urge. You cannot cancel those x to the 5ths. That one on top is a monomial. The thing on bottom is a binomial. They don't cancel, ever. They do not cancel. All right, so just same thing with different variables, making it look a little bit weird. We have the LCD of y. So I'm going to multiply by y on top and on bottom. On top, that's a wy. The y's would cancel on the second term and make 7. On bottom, that's just a w. Can I cancel anything? No. I know you want to cancel the w's, but again, that's a part of a binomial and a monomial. They don't cancel, so I'm done. All right, on bottom of my little fractions, I have w and x. So my LCD is going to be wx. So I'm going to multiply by wx on top and on bottom. Here, the w's would cancel and leave me with 3x. Here, the x's would cancel and leave me with 2w. On bottom, the w's would cancel and it would give me 2x, and the x's would cancel and give me 3w. These do not cancel. They are both binomials and they are not the same. I cannot cancel them. All right, well, that's about it for this video. I'm going to do another one with a little bit different bottoms.